Here we are, guys. This is the end result. This is the version of the car used to make it, to actually create the entire vehicle. So what you see here is the revision 75 used to share with Abel and all the other engineers and everybody else involved to literally bring the car to life. So I want to show you the end result, at least the one enough to make a car from scratch, and then dive into the facets, all of the things necessary to make this come to life. What you see here is actually a mixture of two major components. And of course, they've changed since time's gone on. But the first component is this whole body. The body is itself two models. One is actually the RX-7 body, and the two was a body kit that I kind of put together as an idea of how I would fit the extra width. You can see it from there. Now, that's one aspect of this build. The other aspect is clearly the engineering, the vehicle itself. You can see the suspension and everything fits almost identical to how it looks like in real life. So very impressively, you can see it from this angle. The car looks very similar, almost identical to what was built. So that's a really good sign that FR Performance, Abel's shop, can create what you made to spec. And look at, there you go. There's the drive shaft. There's the, you can see the transmission, everything else in there. What did I build? Let's start there. I got all the dimensions to make the 4-rotor rotary engine, the one that you see there, the housings and everything, just for approximation. I built all of the suspension by hand. I built all of the suspension geometry by hand. I even built the wheels. I did not build the turbo. That was supplied to me. This is kind of cool, is when you have a project going on, you can get things like your turbo supplied to you by, well, Garrett. So I had to sign an agreement that I would, not use that for any sort of manufacturing reasons. But there we go. We got the turbo. We've got a front differential that was actually supplied to me by the guys that built the Hoonicorn. But that's not the one I used. I ended up using an M3 one, so that is not identical. It does not look the same. As well as the struts. I utilized the struts out of a free, I guess you can say a free setup. But they've generally, I enlarged them and changed the size of them to fit the size of mine. As we go into the vehicle, you can see the Hollinger. Again, I signed an agreement that I would utilize this for good. And you've got the Hollinger case, the whole box right there, the RD6. As you can see, the transfer case from R33 GTR is something that I wasn't too concerned about the exact sizes. So I just simply put what I knew would be roughly the size, where the drive shafts would go. And then, again, end result was to see where things would line up and what tolerances I needed for inside the vehicle. But so enough of that. Let's jump straight into the drivetrain, because that's where this all started. So here you go. Here's the drivetrain. And what's particularly impressive about this is I built this without any knowledge of CAD. So what you see here is if the car breaks apart at 300 miles an hour, well, you can definitely point to that as one of the directions of problems. But one of the things that takes a lot of getting used to is the fact that you're not looking at it in a real-world three-dimensional sense. So this is a 3D perspective-based thing. So if you're not familiar with CAD, like I wasn't, this is what you're more familiar with your eyes. You know, the rear wheels are further back there in the distance. The front tire is closer because it's closer to the camera. That is awesome for getting an idea of what a vehicle or things would look like perspective-wise. Like, okay, I'm standing over the car like this. That's what it looks like. But from a CAD standpoint, that's not as important as orthographic. So look at that, boom, everything looks like, well, it looks like if you had a massive zoom lens on a camera, that's what it would do. It kind of crushes everything to the same exact size. What that is useful for is, look at this. You can see that my track width, the center of the tires on both sides, except if you grab this tire right here, is in fact, we'll move this tire, just, you can see that working, on this vehicle, both sides are identical. This was designed for the Hoonicorn, that the vehicle center of tires to center of tire on both the front and rear tires would be identical. That's great for handling and as well as a lot of other things. But let's look at the suspension here. This is very fascinating. Let's look at the front, particularly the front suspension. I built it in two sections because I didn't know how the chassis itself would be built. That's not my area of what I was going to end up measuring. All I cared about was that the chassis connected to my suspension right here. So I supplied them with, hey, there needs to be chassis here, there needs to be a chassis here, and you guys are the experts from there. So what you just saw me grabbing was this right here. This is one of the more advanced features. This is kind of like icing on the cake once you've designed something. So I'm going to show you this again. I was able to get all of these things actuated, which was a pain in the ass. You can see I'm not even going to mess with the shock itself. I got what I was looking for here. Again, I'm giving you guys kind of the end result, so then you can work backwards from here. This is my finest piece. We're going to move a little bit of angle here. Watch this, and watch what I'm looking for. Right there. You see what I'm watching? Look at that upper control arm, which is this piece right here, and see how it crashes into the rim, which again I measured that based off of Austin's specs. Right at that point, it crashes into the upper control arm, which if in real life, that would destroy the wheel or at least scuff it up badly depending on how far you got. So what I was looking is to make sure when the car, after it hit a bump and it rebounded, so the tire is now, let's say you hit a bump, boing, and it goes down like this, or say you get some major air, the tire is going to come down like this once the weight of the vehicle is off of it. I needed to make sure that the upper control arm would not crash into the wheel. Now you're thinking, okay, that's awesome. You know your limits. There are limits, but what's worse is not just vertically, but remember this is a wheel, a front tire, and you can see why I have it turned. Look at that. We're going to turn it a little bit more. The upper control arm is going to crash into it when it's at maximum turn and compressed or going up and down. So what you do is you take the wheel, which I currently have. Let's get it right here. Let's get as far turned in as we can. And what you'll notice, a very fascinating part about this build, is look at that. The angle of the upper control arm piece right here. Let's see if we can get this to turn a little bit more without it'll freak out at some point. Again, I'm not an expert at this, but you'll notice that this cut, this divot right here, matches the tire. And I'll be damned if in real life it does the same thing. It is impressive. That was partially a design cue on ASD's design, but I happened to do the measurements and come up with the same thing, which sounds simple, but it was a lot more difficult than you think. Sure enough, this is kind of a pain in the ass, but it does the same thing on the rear upper control arm. So it literally connects into that divot, and this angle right here, sure enough, the back of the tire, back of the rim, hits that. So that gives you your maximum turning radius, your maximum turning angle for each side, given the suspension going up and down. So that's something that you have to keep in mind. It's tons of things we're going to be juggling with this. But yeah, so what's nice is the lower control arm is more pointy, so you really don't have that as a concern. It's the upper control arm that's really the pain in the ass right now. Really impressive stuff there. So again, I'm trying to show you the end result to motivate you as to why. Oh Jesus, that's exactly what would happen a lot. It's going to crash into itself. I want to show you the end result so you can see why you do some of the smaller pieces to this. What's absolutely important is I built the suspension. So when you look at the car, these control arms, these lower control arms, this upper control arm, this cantilever, and the wheel hub, which is the hidden hero of all of this, are all built from this model right here. So it's really kind of terrifying and impressive that this is the real car. Like, it's not just, oh, hey, this is a cool redesign of it. No, these are what we used. This piece right here is what ended up being the car. So kind of terrifying and awesome at the same time. So let's start at the beginning. Absolute very beginning. This is where things get really interesting. Not only did I have some help from the guys that built the car, but they got really busy and didn't respond to my messages for several months. It would be a little bit at a time. So I had to take things in my own hands. In this case, I will say I reverse engineered this vehicle right here. I was given some information. I had one major phone call that lasted about 2-3 hours. Other than that, I found a lot of information on the vehicle in this diagram, in this document right here from Speed Hunters. So a huge thanks to actually the guys from ASD, Vaughn Gittin, the guys at Speed Hunters, for producing this sort of documentation. It was enough imagery and enough content to help fill in the gaps that I was missing. So if you get a chance, check this document out. It's pretty badass. But what you see here, this picture right here, was one of the key parts to me making this possible. Again, when you look at things in perspective mode, which is on CAD, things are skewed. You can't measure things based on pixels. But when it's in orthographic, look at this. You can actually measure everything based on pixels. So if say you knew the height of this piece right here, and say it's 5 pixels tall, well, 1 pixel is a quarter of an inch. Then you measure how many pixels wide it is, and you go from there. So yes, I literally did do that. And why that mattered was I needed to know how wide these control arms were from this angle. I didn't know. So very fascinating that is, in fact, I knew how big the brake rotor was because I knew which brake rotor they used. They used it out of an '08 Corvette. So because I knew the actual diameter of the brake rotor, that was the measurement I used to then reverse engineer how tall and how wide the control arms needed to be. Crazy that is literally what I did. That was my break in that picture. This is the next most important picture. Again, I'm looking at angles. I'm trying to estimate things. Now, was much more difficult, and it gave me just some reference material. But you can use it to say, okay, I see that this is about this wide, this is about this long, and go from there. The problem that comes into play here is you do have angles, and you start having to use more geometry instead of just flat 90-degree simple things. Fortunately, they made this one, and it got much closer. So again, I'm talking about approximation here. Is that I'm telling you guys the truth right now, is that I was able to figure out the height of things and the distance of things based on this document right here. So once I figured out that, okay, this one's this long, this one's this long, that gives me an approximation. So this is truly, what you're looking at is truly how I built this thing. So you're saying, okay, that some of these, if you guys are kind of sharp-eyed, you're going to say that's not enough information. And you're 100% correct. There were pieces that I had to figure out with more information. Scroll down here and you start figuring out how I did it. They don't tell you any specs about the car on here, but they sure as hell show you pictures like this. Again, this is something where this picture is actually in real life, so think of it this way. A piece of metal up in the front here, let's zoom in. A piece of metal up, say even this bolt, this lug nut or bolt right here, is going to be much larger than something back here, in the sense of inch per inch, because of this is perspective mode, this is real life. So what I was able to do though is, this is again literally what happened. I didn't know what size heim joints. You look at these joints right here. I didn't know what size they used. And so I estimated that based off of what I knew from the CAD again, was how tall this piece of metal was, how wide it was, and then I estimated how wide this was within a margin of error. So I was able to figure out that these were in fact 7/8. The thread on them are 7/8 inch heim joints. So crazy pieces like that where I still wasn't 100% sure, but I was able to figure out with some certainty what was going on. What you'll see here, we'll go into a whole different document about the suspension geometries themselves, but you'll notice first and foremost that the lower control arm is flat to the ground. That is by design. That is very much important. The upper control arm slopes downward as you go towards the engine. Very important facets, but the other most important facet that was confusing as hell was the fact that the upper control arm slants downward as you go to the front of the vehicle. That has to deal with squat, anti-squat, and anti-dive, as well as putting power to the ground. So there's a lot of aspects going into play there. So as you can see here, I utilize as many of these pictures. This is one of the tricky ones here. I utilized a lot of these pictures to figure out what the hell they were using. Again, widths of these things were important. So the question really becomes, how did I turn pictures of this car into this with any sort of absolute certainty? There's one small missing piece, and I swear to God, if you guys share this or utilize this, I'm going to be mad at you, because this is information that I was given, not the information that I created. So here we go. This is the most important piece of information that I was given from ASD. I'm going to blank out some of the numbers here just out of courtesy, because this is not my years of research. This is theirs. What you see here is the only piece of information I was given with absolute measurements on the Hoonicorn. You are looking at the Hoonicorn's front suspension geometry. This is it. So what does that look like? That is, well, that's this vehicle right here, because all those things are still the exact same. That's this front suspension right like that. So here's where I started figuring things out. They were telling me how tall the chassis was, how tall the suspension components were. What you really see, and it's kind of hard to mark it up here, but you can follow the mouse along, There's the lower control arm down here. Here's the wheel hub, the whole assembly, and then here's the upper control arm here. Then, of course, you've got suspension mounting components. You see these dots right here. This dot is the, well, both of those are where the point where it flexes. So remember, because of Heim joints or any sort of joint situation, the actual point it rotates is, well, an inch, 3/4 of an inch away from the actual suspension or the chassis. So that came into play there too. But looking at the right side over here, you can actually see the wheel. You see the outline of the 26-inch tall wheel over here. And what's very important about this is there's a couple key things we'll be going over in the next video. For example, see this angle here? That's called kingpin angle. That's the angle from the front point of view that the tire turns off of. So it's not completely vertical, and there's a couple reasons why. As well as this little bit down here, this 0.8 distance, that is called scrub radius, and that's when you're turning the tire. Is the rotation of the tire on the center of the tire or in or out a little bit? People that erroneously put massive wheel spacers on stock suspension end up having a massive scrub radius. So what that means is the outer part of the tire is getting hit by rocks, the inner part of the tire is getting hit by rocks, but the rock on the outermost edge of the wheel has leverage more so than the innermost, causing the steering wheel to jerk from your hand when you hit bumps and or debris in the road. So that's highly unfavorable, unliked when you're creating suspension. So starting from scratch, this is completely re-engineered. So you can see I've got about a 1% camber gain. Well, camber at static, and of course, as the wheel goes up, it increases in camber to make sure that the wheel stays flat, or at least keeps most of the wheel's traction on the ground. So how did I turn that image of measurements into this? Did I just start creating suspension components in 3-dimensional and let it go? No. Those of you that want to skip to the good stuff, kind of skip ahead and watch the stick figures come out, but those of you that are more interested in the CAD, you'll notice over here I have all of these bodies, and a lot of them are turned off. I purposely left my historical images and pieces and components to show you how I got here. So bear with me as I uncover and dust off the very first version of my suspension. You'll see them illuminate as I mouse over them as well. But let's see here. Actually, you might not see them illuminate because they're hidden inside of this suspension. So we're going to move it over like this. Yeah, there you go. See those things lighting up? Those little sticks? Those sticks are my original suspension. What I did was I measured them, and of course they're 3-dimensional, so I did measure off of one edge, but I measured them to the specifications of this image. So there's no surprise that you'll see them up close coincide with those suspension angles right there. So let's go back to this, and I'm going to go ahead and turn 110, 111, 112, 113. Yeah, we'll even turn on the ones I used that I knew. So even this 104 here. Now we're going to scroll down and figure out the real suspension. Right here, we'll turn off 107, turn off 116, and then you're going to start seeing things pop into place. 115. You can actually, I think you press and hold it, parent. This is a component, because some of these were built. You can build them in like a separate, basically a file just for them, and then add them into this document so they update when you make changes to that specific thing. So you can send people just pieces. So we're going to go ahead and, oops, they're under bodies as well. We're going to go ahead and turn off some of these components. You can see them in here. So there we go, component. Turn that off. This wheel hub. Let's look at its parent. That's body 192. We're going to go ahead and go back up. Here's 192 and turn that off. And so what you see here is the beginning of the suspension geometry. So you can see the axis angle right there. See that dotted line? That is the rotational spot on the tire. And sure enough, at happens to coincide with going straight through the center of those two pieces there. No surprise there. So you can see this is literally what I built. I built this little stick here, and if I recall correctly, yep, there we go. The tip of the stick from very front angle, again, this was rudimentary, but this is how I did it. The very tip of the stick goes to the center of where it's supposed to axis, it's supposed to rotate from. I didn't plan for joints, I didn't plan for anything other than this is the correct length needed. And then of course the center piece as well here, same thing, and then this piece here as well. So you can see that's what I built the suspension off of. They don't even touch, they were just simply a two-dimensional reference. I'll back up. Good old steam firing up. There's simply a two-dimensional reference for me to start building the correct dimensions and figuring out, okay, the control arm needs to be here, the wheel hub, and so on, and so on. So those sticks are how I started the suspension. And if you look, we're going to look at it from almost a straight angle, this bar to this bar to this bar, go back to the image, and there you go. There's that bar, and that bar. So that was my very first blind step into getting this done. What you see down here, this is a very interesting contention with the whole project. This, it should be actually, well, yeah, it's this one. I purposely built this one under the car. So this length of this piece, 6.98 inches, coincides with the 6.5 inches here, but to the center of the control arm here. So if you add and ultimately figure things out, yeah, there we go, 7.3. It does add up. It's the angle that I'm showing you from might be a little off. I haven't updated these in a while. So you then look at the absolute center of the car. Let's click on back so we get the center here. And you should see something. This is 33.3. And of course, well, 33.38, which is 33.4. And that's literally half of 66.8. So what you could see is I was actually building a framework, and this is, again, me as a individual who doesn't know much about cars, or I should say knows a decent amount about cars but doesn't know much about CAD. There's the framework of me trying to build the car and the front suspension. So I was building all of these dimensions in CAD and then working from that. So that's pretty crazy there. I'm going to do one whole video on building this whole wheel hub because holy fuck was that difficult. This was one of the most difficult things in my life because what you're looking at here is Vossen asked me before SEMA, they asked me for the wheel specs. And if any of you are familiar with how wheels are built, they have an offset, they have a width, these are 10.5 inch wide tires, but on top of that, those little bad boys are, have an offset from the center. And I had to figure in, this is a kind of a preview, I had to figure in, we're going to back out of all these pieces so you can see this come to life. There. I had to figure, actually, I think I even have is the brake rotor on this one? No, it's on this one. Watch this. This is going to be pretty badass to see. I turned it off because of how much performance it takes up. Their disc brake assembly. So what you're seeing here is not only did I have this disc brake assembly, not only did I have this wheel hub, but you have the actual wheel there. And this wheel right here is the measurement that I used to send to Vossen the exact wheel specs to be built. Ultimately, so the rubber would fit right the way it was supposed to. So take a look at let's turn off the tire again, because this is where I think this is one of my personal favorites. Go back to body 107 and 116. And so that is the correct disc brake. At least I've modified it so it would be the correct size. So then you see I had to build this wheel hub, the disc brake. We're going to scroll back down and turn the disc brake off because the thing that blew my mind was the wheel bearing and how that attaches to the wheel hub. So we'll cover that in a whole separate video just in case you're really interested, truly interested in the exact process to machine your own car and do all the correct suspension geometry. You'll be able to do it the same way I did and save yourself some time. But hopefully this shows you guys, these videos are going to be long and grueling, but hopefully this shows you guys the countless hours needed to build this car from scratch. And I know that all of you that are supporting it understand how much of a undertaking this is, but you realize that this is no joke. This is not just me dicking around. I know that you know that, but you can see why this thing's going to dominate so well on the track is all of this is thought out. This isn't just tacked together. And there you can kind of see the whole suspension thing there. This is actually one thing that changed. Just a real quick last piece is that at the last second we moved the rear diff up, and you'll see the exhaust runners going under and then over to the exhaust manifold, so that way we can allow the front drive shaft to go through. So that was a minor change that we have not reflected in this. But yeah, we'll go over each of those aspects of how to build these control arms in CAD, how the suspension geometry was built and figured out to do true wheel specs, and then another one on suspension geometry in the sense of these cantilevers and shocks. I learned a fuck ton there. And then, of course, as we continue going on, good old animation and what do you look out for with those. So there's a ton of suspension geometry to cover. And this is not supposed to be some sort of like educational, but it's not supposed to be like a teaching thing. This is just sharing what I found. And when you absolutely are screwed and forced to do it at the last second, this is what you come up with.